Hello and assalamu alaikum everyone. This is the group project video for the subject microprocessor EEE3132. The name of our project is gas leak detection using PIC microcontroller. My name is Mohammed Tanzim Rashid and my metric number is
And
20498.
my name is Liu Tao. My metric number is 199645.
The name of our lecturer is Dr. Izal bin Abdul Halim. Next place please. All right, so here you can see the contents of our project, what we'll be containing. At first, we'll be going over the objective and introduction and the contents of our project. And then it will follow through the flowchart and software design, where we'll be explaining what kind of software and why we are actually using it. And in the schematic design and simulation, you guys are gonna see what kind of circuit have we actually made using the softwares, because we can't make it physically. Then we'll be discussing on the project, and also we'll be concluding with what kind of future opportunities we can get using this kind of project ideas. Okay. Okay, so the the main objective of our project is to develop a circuit for connecting a gas sensor and other output components to PIC microcontroller. We used MPLAB software to design our C programming and also used a Micro Pro to debug and build the program system to get the hex file in order to implement them in our schematic design, which was also done by a software called Proteus 8. Also, during our work, we got to know more about the shortcomings and the profits of having this kind of circuit design. So, which actually helped us to realize what kind of disadvantage and what kind of improvement we can get, and also its compatibility. Thank you.
Okay, for introduction, gas leak detection system is an important part of the safety system, and it is the first line of defense to prevent the disaster caused by gas leak. It detects gas leak and trigger an system to implement safety precaution. Some leaks are too small to be smooth or odorless, so installing a gas leak detection system is a necessary investment. The use of gas in industry and resistant environment is increasing. The gas is mainly used for power generation and as a process requirement in the manufacturing industry. Regardless of the size of the leak, the consequence of a gas leak can be devastating. devastating. Okay.
All right, so now we see the flow chart. As we can see that we actually plan to use a gas sensor to our system so that we can detect gas. In case the gas sensor detects gas which is above the set limit that we'll be doing for using the programming, or it's above the harmful level, it will signal the microcontroller to turn the LED blinker and the buzzer. And also the LED microcontroller will start showing gas detected in the LCD, which will notify the residents of that area, or any other people who have the connection to the LCD to it. And in case the amount of gas in the atmosphere is not harmful or less, then everything will be turned off. And also the LCD will show that gas is not detected. That means it's not in the harmful level, and the loop will keep on continuing until there is any sort of stoppage or any sort of lack of power. In case of power source, it gets destroyed or something. All right, next page, please. Here you can see the schematic design, and here we have used three different power sources of the same voltage, but we can obviously reduce this to minimize the cost. Just for the convenience, I use three different power sources. The gas sensor here we use is MQ2, which is quite cheap but very dependable in case of result. The microcontroller we used here is PIC 16F877M, which has ADC conversion ability and also has PWM connections. The PWM models here, that is CCP2 and CCP1, I use these connections for my LCD in order to minimize the amount of energy loss, and so that I can control the device more smoothly. And also this function can be enhanced by further research and stuff. And here for the gas sensor, the 1 and 0, the toggle system shows that the analog values, that is the gas that is detected here. All right, next page please. So this is the PCB layout, which shows the connections between the components. After we have synchronized our schematic diagram with our program, we use the Proteus software to get our PCB layout. And after the PCB layout, we'll get a 3D model of it. Once PCB layout confirms that there is no kind of signal error, and we found that there was no error, there was 17 connections among all the components. Next page, please. No, no. Go. Here we can see a 3D model of our circuit design, and all the connections are also shown in the background, in the back side of the board. Yeah, next page, please. Here is the simulation of our circuit and also the values found for the input and output in the oscilloscope. As you can see, the buzzer and the LED is working properly, and also the LCD is showing what it's supposed to show when gas is detected. And here I changed the AC connection and DC connection for the oscilloscope for the input value to check what kind of current we are getting. Here we see that we are getting 5 voltage of direct current continuously, so the system works smoothly. All right, next page. As for the problems faced during this project is mostly containing of different kind of errors in our program and problems regarding synchronizing the hex file with our schematic. However, it took a long time, but I got to learn a lot about it, and also because of my research, I got to know a lot more about this subject than I previously used to know. And also, I hope that this circuit can be used practically, in practical sense. Thank you.
Okay, for the conclusion, all in all, nowadays there are many unexpected things in our life, such as the mobile phone charging is likely to explode, or the like when we cook a meal, the rice cooker is bottom out, produce uh, peculiar smell, or we don't pay attention to the room where it's on fire, smoke. These are very dangerous. It's going to affect us. So in order to avoid the possibility of this kind of things happen, we build a device that can detect the passing gas in the smoke so that we can be allowed to occur currents of similar events and take a protective measure in advance. In short, this device is designed to help us reduce the risk of something dangerous happening. On the whole, our experiment is basically complete.
Thank you.
So, thank you.